Good afternoon, everyone. Welcome to this session on the mastering data complexity in the process industry and how we are able to bring in AI, GenAI in managing this complexity. Uh, Thank you to the distinguished panel. We have Sanjay Banwal, Vice President, Oil and Gas, Chemicals and CPG Industry. We have Dave Croning, uh, RMD and Asset Management Leader. We have Vikas Maurya, Global Product Line Manager from AVB, and Larry O'Brien, from Vice President from ARC Web Series. Thank you, all of you, for being part of this session. Each of the panelists represent the specialty in engineering, on the OT and controls, on the AI and predictive asset management, and from a controls and cybersecurity. So we'd like to have a session talking about the process industry digital transformation, where we have a surge of data integrating ET, engineering data, OT data, and information technology data, how the digital transformation is being handled with this surge of data. We would like to have an interactive session with the panelists, bringing in their experience from the industry. Thank you. To the audience, you would have a side panel questions. You can scan the QR code, and basically you have to have an option. I think you scan the QR code with the apps, you'll be able to respond. And coming to me, I am VP Digital Engineering from L&T Technology Services. L&T Technology Services, we are a $1.2 billion company. We are into sustainable engineering from the plant engineering and industrial products. We are into the mobility business and as well as into the high-tech side. We are very purposeful and agile in terms of how we handle, and innovation is the key in terms of how we adapt AI and GenAI into the industry. And getting into the session, we start with basically in terms of the industry trends when it comes to the fusion of the data, ET and OT data. I'll start with Sanjay. The question is, from an industry perspective, how do you see the digital transformation in the greenfield and the brownfield projects is being handled when it comes to integrating the engineering data from a life cycle point of view, from a feed to all the way to the decommissioning point of view?
Thank you. Can everybody hear me okay? Am I audible? So good afternoon, and thank you for this great opportunity to interact with you. So my point of view is the engineering aspects we all know is foundational. Digital twin is about engineering, IT, OT, and a seamless way of connection. Now, if you look at in last 10 years, except that GenAI or Chat GPT kind of tool has happened, nothing has changed. So if you think about a digital twin of a plant or an asset or a process, by now, we all should have. But fact is, none of us have. I have worked with 50 plus customers, and everywhere you can see some portion in a plant or an asset or a line level, you'll have a digital twin. But can you really take this glass and do a model of this and relate it to how it is operating in the plant or in going to customer support? It's a dream. We have done 20 years back. Many of us have done. You have been part of this industry. But today, fact is, it's not part of the mainstream and it's still transformations happening. So I'll address what's happening. What is the trend? The first fundamental what I'm seeing is when you are doing greenfield, and I'll come to the brownfield second. Greenfield is, as a customer, have you chosen your platform? Because your design engineering team is there, then your procurement team is there, and then the EPC comes. So I see a lot of places, and it's a recommended in my view, that you decide whether you are a Hexagon, a Viva, or Autodesk, whatever. You need to have your own say. This is how I want the digital part of my plant or a line or an asset to be designed. If that standardization is not there, what we see commonly, the design engineering team will do at a concept level or a feed level or a detail engineering, like we get involved a lot, we will do it. The EPC will take it, will do it, hand it over to you. You are too busy in getting that plant running. Now, finally, they will transfer all this information to operations, and that information has to be integrated with your rest of the enterprise, managed for next 50 years. If you don't pay attention, you don't have the standards and all, EPC will do finally dump it to you 10 to 20% right away is unusable. And over a period of time, that has become outdated. Now, 3 years down the line, there will be another initiative to clean this up. You have a great choice for the greenfield probably. You do all the simulations, you can do predictive, automation, everything possible. But have that standard in place, platforms in place. Take a golden site, have that in place, and then you can, now your foundation is ready. Right? So my advice, what I'm seeing already, some of my customers are thinking, every single customer that we are working, I see there is a central command which is trying to decide which is my platform and recommend it. Now it comes to the greenfield is easier to do, right? You are starting afresh. Now the brownfield, so much of legacy platforms are existing today. So we are doing a lot of laser scanning and creating those tags and mapping to the, again, the standardization comes into picture. If you do not have the global standards, your SAP data can be up to date, but then typically IT companies come, put the script, move from 5 platforms to the your SAP, and you don't have the standards. You are not, disparate systems are not connected. So those are the things people are focusing on, the data part. Data lake everybody is creating, but that data lake also, if you put shit in, shit out, what will you do with that?
Yeah.
Right. So that will be my answer.
Thank you, Sanjay. I think, yeah, you have covered a lot of ground in terms of how the challenges are there. So coming to Dave, like while when it comes to the data being integrated, I think Sanjay is talking about engineering data. Now it is on the digital transformation. So how is the data being managed when it comes to transforming the data for the, whether you talk about operations performance or the predictive maintenance part of it. So how is the data being managed across?
So in my group at Ag and Energy Solutions, we leverage the data, which then gets translated into models, and our focus is to help increase asset reliability and performance that way. So we depend on the data that comes in to support our models, and if the data is not available, it's not reliable, we're definitely going to struggle, and we're going to be deficient at doing our job. So a lot of times what we'll do is we'll focus in on the assets themselves and look at what data is available. And then we'll work with the OT team on understanding what our expectations is on the frequency of the data that's coming in. And then partner with the IT team as well to build tools that we can understand what the quality of that data looks like to make sure that our models run well. So on our end, with the dependency on the data, the key is really making sure, no matter what you're monitoring, from our standpoint, is do we have the data availability? Is it the right quality? And then for us is, at the end of the day, do we trust it? So, that's our role with the data set.
Thank you, Dave. So while we are talking about data, the data source itself on the controls and OT data, so there is a legacy product lines, legacy control systems, there is a new generation product lines. So because primarily the question is, how is the industry adopting to the technology upgrades, refresh? But at the same time, you have a lot of process industry which is having legacy control systems. So how are you integrating them, bringing in the data?
Yeah, so we at ABB, I mean, for us, when we digital transformation programs, they come to the layer we are dealing. We are primarily kind of supplier of control systems, and control systems is generating a lot of data, collecting a lot of data from the field. And when we have to do the digital transformation or support the digital transformation programs, we need to get this data out from our control systems, out from the OT layer, going up to the IT layer, where you can leverage the data for different purposes. And we deploy, it's an edge platform there in between our control system and the IT space. So basically the spot is like OT IT convergence. And we get the data in a safe and secure way. So one of the things which is literally for us important and also for our customers important, that we do not disturb any kind of core process operations which is ongoing. So there's reliability which we have to ensure with our DCS. Is thousands of systems installed across the globe, and the data need to come out of it, but nothing should be kind of forking into our DCS system. Nothing should overload our DCS system, so that the process which is running is kind of uninterrupted. And then that's what we do at ABB, try to put an edge platform as a layer above the control system. Either greenfield or brownfield does not matter, but this is a separated layer where we get the data out. And that's the key part of it. And we bring this data also, basically, since the applications need to consume it, so we need to preserve the context of the data. So data already need to be at the edge within a kind of a context already available, so that applications can leverage. You can do things with the data on the edge, or the same edge can also push data to the cloud. So that's what we are mostly focused. We see our customers asking, get me the data out, get me the data out, but please do not jeopardize anything what is running there. Yeah, that's what we are kind of building and trying to protect our OT systems with any kind of things ongoing in the digital space. And at the same time, we have to support all the digital transformation programs which our customers are running.
Thank you, Vikas. So Larry, from your area,
I'll comment on that.
yeah,
Yeah. I'm a cybersecurity guy, but also a process automation guy. And as you probably know, there's a huge installed base of legacy systems out there that are quite old. It always surprises me how old some of these systems really are, right? And I agree with what you said. A great way to handle, getting data out of these legacy systems and up into a modern, digitized infrastructure could be an edge system, or what I like to call an IoT data platform, right? Which is really a common layer of abstraction that can sit on these legacy systems, regardless of what type they are or how old they are. And that allows you to bring everything into a common environment and kind of put everything into context and, make some intelligent decisions at that point. However, securing these things, can be a real challenge, right? I know, how many people here are actually experimenting with digital twins right now in some way? A lot of people here. Have you given thought to the cybersecurity aspects of those digital twins? I'm willing to bet no. And I'm not trying to disparage the suppliers here. I know they take steps to make sure that these digital twins are securely implemented and everything. But I don't hear a lot of discussion about security, when it comes to this. So this is something that you really need to take into consideration, right? Where's the data coming from? How are you securing how that data gets into your digital twin? If you have an IoT data platform, what steps are you taking to secure that IoT data platform? And that gets into a lot of issues like the supplier selection process, right? You have to make sure that whatever supplier it is you're looking at has the correct, cybersecurity measures in place, and or certified products, or certified secure development lifecycle process, or what have you, right? It's kind of a multifaceted issue. But one thing that does concern me is we don't hear a lot of talk about cybersecurity when we start talking about these things. One of the things you asked me earlier was, do you think, cybersecurity concerns are holding people back, from implementing these digital transformation programs and so forth? And they're not really, which is good and bad. I mean, we don't want to get so bogged down in cybersecurity that we, don't implement these digital transformation programs, and we miss out on all these opportunities that they have to offer. But at the same time, you need to consider the security aspect of what you're doing.
absolutely.
Yeah.
Yeah. So while cybersecurity is a check and balance, because technology upgradation is happening very fast, ready to deploy. But yeah, I think cybersecurity teams need to make sure that they're secure in terms of how do you really deploy and how do you manage them, right?
Yeah. Yeah. And it's not something most people want to think about a lot of the time.
Yeah.
I think a lot of times we sit up here and we talk about cybersecurity, and it's kind of like, brushing your teeth and, and things like that. And people would much rather talk about, how cool digital twins are and stuff, but don't neglect the cybersecurity aspect of that.
Sure. Thank you. Thank you, Larry. So just we want to move into in terms of the core challenges when it comes to the technology integration of the data. So Sanjay, the question would be, what are the key challenges when you try to contextualize the engineering data? Primarily, when you talk about digital twins, you need to overlay and contextualize your P&ID, PFDs, and in terms of the site-specific asset data. So, what challenges you would see when you're executing the programs?
See, there are multiple challenges I'm sure most of us have been through.
And
right?
also, what solution approaches you
Yes,
follow? Yeah.
yes, yes. So I'll come to the theme of the standardization which I was talking about, right? So first thing is look at the way you do your engineering data. There is a standard for engineering, capturing the engineering data. Now there is a standard for IT and OT data. Within IT also you have various standards, right? You go to the OT, control and automation, so many protocols. Within your company, I'm sure there are 5 different solutions from 5 different suppliers are there. Everybody's talk about that getting the data connectivity. You can connect, you can sensorize and all, right? But finally, when you click on that PNID, everything associated with that PNID, all the simulations, all the history of the parts, everything has to show up. And if any one system is not connected and doesn't show up, first time your guy in the operation guy, right, he will click. Second time he will click. Third time he will just not click even. Doesn't matter what you do, right? That's the typical challenge. It's just like 10 years, 20 years back when we were rolling out the websites, right? And if website is not intuitive enough, 1, 2, 3, you are gone. You'll have to rewrite that website again. Nobody is going to use. Same thing is happening here also. So what we need to very clear the use cases that you are identifying. I came across one of the solutions, one of the customer here is speaking. We were working for that and we created this solution, right? And you can talk about Gen AI, everything. The guy who was doing simply a manual activity, which was in a one shot hand, he could do that. You created 5 layer of applications where he had to click 3 times, 4 times to do that same work. Are you going to get it? You're not going to get it. So that's where I think those challenges we need to understand first is that and sometimes it's a silos also organizations engineering, IT and OT. Somebody in one of the customer organization that I worked on, they were so frustrated that they were finally not able to connect the dots and take the benefit across the value chain, right? Because engineering will do, I have automated, everything is fantastic. Quality says I'm doing fantastic job. Operation do none of, and then finally the end product is not getting the downtime and all is bad, right? What they did is they created a central figure from the operations, reporting into the engineering, reporting the IT, and they created a core team so that the cross-functional behavior is aligned.
Yeah,
There
and
is
also Sanjay, like when it comes to engineering data and documentation, right? Like your most of the plants are legacy plants.
legacy.
So the documents are not really digitized. How are you integrating your engineering design and your PFDs and PNDs also are not in digital form? But if digital twin needs all the data, they have to be single source. How
So
are you
what we are
extracting?
doing, and most of us, I'm pretty sure you are doing the laser scanning, right? I saw there is a VRAM company here. You should visit them. So typically, what we are doing is the big corporations can afford that you do the laser scanning and you will create the 3D model because now you have the CAD model. You can do simulation. You can do many things and integrate with the rest of the enterprise if there is a brownfield coming, right? But some of us, what I'm seeing, customers do not have the fund to take the laser scanning and create corresponding CAD model. I saw this right in this booth here. You should visit. They have that same model, that is scanned version. You can start associating the PNIDs and all. So you don't need the CAD model. Maybe you need to. So those are the approaches. We are taking 3 approaches. One is you have paper documents, right? Can you apply some Gen AI technologies rather than scanning and putting those tags and all and build the whole data model? Use some of these latest technologies available, some of the tools and platforms that you don't have to go through the CAD. Or in middle, you have to be at the CAD model because you want to build, you have enough funding and money available. Then second part is the optimization is all right in the CAD you can do. And the biggest challenge what you are seeing is you create this engineering model and then this is a static model, right? A static data. How do you connect to the real-time data, which is your sensor data, your ERP, MRP, your spare parts? So this is where the contextualization, like Cognite, some of you would have, I'm sure you are talking about that. Cognite, the Conswork, the PCMS. These are some of the tools and software platforms which are matured, supported by different suppliers. Maybe you should consider. So like a platform like Aviva or a Hexagon can give you the engineering static data, but the contextualization of this model to mapping the so many of the real-time data happening. That's where we are trying to help. And now once you have that contextualization, you can take this design to a particular glass of bottle that you are producing. You can analyze that behavior and do everything around that. And
Yep.
then you will leverage the full benefit.
Thank you. Thank you, Sanjay. So I think the question is, Dave, like the data is available, you have context live, but still the analytic models what you're developing to asset performance or process performance, what is the challenge in developing the reliable models? And the process engineers have to an acceptability, right? In terms of how do they trust them?
Yeah, and in our space, so we have a lot of challenges. There's no shortage of challenges. I think talked a little bit about data quality to start, and then as we think about in our space, we deal with a lot of false positives. So really, how do you understand what a true positive is, and how do you find that in the mix of false positives? And so it depends on the data quality, and also if you're in our industry, variables change, right? Temperature comes in, that swings the plant, it goes up and down. There's so many different considerations there. So the third thing that helps with that is really the context. And to build on what Sanjay is saying, we did start an effort with the Cognite platform to really help with that. It's a little sliver into where we can go as far as bringing the knowledge to the individuals to make the right decisions on some of these models. But as well as when we go forward into, we'll talk further more maybe about some of the advanced things that are going on. But to have an understanding of where you deal with those false positives and the information that you have to make the right decision, to then build that confidence to share with the facility and the plant that we are our customers that we partner with. So those are a lot of the challenges that we have. But at the bottom line is that if the data is not coming in, the models won't run, right? If the data is not reliable, the models aren't going to be reliable. And if you're in a process plant like us, if you ever heard the indication where we say, hey, we have overall vibration is high, and then a vibration analyst goes out to the field and takes another set of data, right? And we kind of like, hey, we had the data here, so do we trust it? Is it reliable? Those are some of the challenges that we face in our industry.
Just one thing I would like to add. Everybody is talking about Gen AI. Now, AI, Gen AI, where does the AI play? Agentic AI, everybody is talking about, right? What it is that you have a play in this kind of situations? My view is that Gen AI is where you have part of something for the large language model. Somebody has like Chat GPT and all the publicly asset information, any information which is publicly available, probably it is part of some large language model by now.
Yeah, so Sanjay,
Yeah,
we'll come
yeah,
to that.
yeah.
We'll come to that. So we'll cover in terms of how actually Gen AI is actually coming to picture. Yeah. So otherwise, yeah, predictive models. So Dave, thank you. I think the question would be in terms of validation of. I think we'll cover a little bit detail. Thank you for that. So because on the OT side, the challenges in terms of how while digital transformation needs a standardized operations data, we still have legacy systems. So from an ABB point of view, what is your digital strategy on integrating the legacy controls data?
I mean,
And also
yeah.
multi-OEM data, right?
Yeah. So, I mean, but I see more people are pointing out a lot on the data, which is coming from the source, and source is, of course, the OT systems, which we kind of managing with our control systems. And yes, I mean, when we get things first thing on the edge, is we're getting this data out for these applications, which I think other companies and applications trying to use. So for us on the edge, when we get this data, for us the key challenge is to ensure the data integrity. That's what you are also talking about, the data which is coming. Can you trust that data? And since it is coming from our own control system, yes, we can ensure that the data is something which is trustable. We are getting the data with the right quality. We can indicate if the data is not coming, or is it bad quality data? So that's what we try to ensure at the edge. The data integrity is there. Also ensuring the fact that data is contextualized, so context is always preserved. If something is changed, does not mean that the context has been broken. And ensuring change management, right? So this is probably another big challenge for everybody. If there are something changing on the OT layer, someone has modified something, is that the change propagated automatically on the edge, right? Not clicking 5 times before the change is again reflecting on the edge and before application can consume. So these are the key things which we are focusing on the edge, and that's really key for our success. That when we get the data out, it has the data integrity, it has a preserved context, and it can handle the changes happening on the control system layer, right? Security is of course another concern, and I will keep talking about it because we need to protect the OT layer. We do not leave it open for that. Integrating data from other OEMs or also supplying to other OEMs. I mean, we go with like an industry standards, which is OPC UA. That's what we rely on. So if we integrate data more than our DCS coming from other sources, sensors, everything, our clear strategy is to map that data to OPC UA, and that's what brings the data on the edge and get it contextualized, right? And and the same way, if we need to share this data out to anybody else, OPC UA is again the way. So we use open standards. That is the strategy. Follow the open standards, get data in a standard format so that everybody else can understand, interpret, and consume.
Thank you. So Larry, again, from a cybersecurity point of view, across the ISA 95 layers, how is process controls to the digital transformation? What are the cybersecurity solution approaches you're seeing? How do you address those challenges?
Well, I could talk all day about that.
Yes.
I want to zero in on one
But
thing
only
though
2 minutes.
that you mentioned. Yeah. And that is, so we've been talking about systems, right? And that's fine, but there's things that go beyond, the central control system. Yesterday, we had a really good discussion about the cybersecurity of third-party packages, OEM skid-mounted equipment and things like that might exist outside the core of your central process automation system, right? So how do you determine how secure these third-party packages are, right? How do you treat these third-party packages in terms of putting them into the context of zones and conduits and things like that? And I don't think there's really a standard yet, although we're working towards that for security of third-party equipment. But that's definitely something that you want to keep in mind in terms of the overall, security schema, of your plant. I know you mentioned OPC. I think OPC has a really good approach to cybersecurity. If you look at the Open Process Automation Forum, I think they've largely incorporated, in addition to 62443, they've incorporated OPC UA cybersecurity mechanisms as well. So that's something to consider. As far as how do we handle security in all those different layers, we at ARC, we kind of look at things below, level 3 or 3.5 or whatever you want to call it. We actually see very few attacks that directly attack the control system in the OT environment itself. A good example of that was the Triton attack, that happened probably 10 years ago now, right, where they actually went after a Triconic safety system and tried to dynamically reconfigure the system while it was in operation. Unfortunately, the system shut everything down like it was supposed to. But most of what we see is actually attacks at the IT level or the enterprise level, if you will, that kind of make their way down, and it causes an OT level shutdown. The Keystone Pipeline example is a really good one, right? So here's an example where they got attacked. It hit their billing systems. They could no longer see what was coming in and out of the pipeline, in terms of the money that was flowing. So they had to shut the pipeline down. I don't think we can really distinguish, the enterprise level from the OT level anymore. I mean, the two areas are so intertwined right now, that what happens at one layer is, could have a negative impact on what happens in the other layer. I'm not saying we shouldn't, segregate the two domains, and I think maybe you're about to mention
Exactly.
that.
So,
We do need to segregate them. We need to follow 62443 and have proper segmentation and, and defense in depth and zones and conduits and all that kind of thing. That doesn't mean, that you're completely secure from anything that might happen, at the IT level or the enterprise level.
Yeah,
So,
I mean, nobody guarantees that you can completely secure, but
yeah.
we are trying to put this safeguards at the edge level that anything goes in or goes out from control system is coming through the edge only. That means you can at least have chance to kind of ensure at the OT IT convergence layer you can validate anything which is going out, be sure what is going out from your control system. And also if some application want to write back to control system to operate the field, we have provisions where we have following again Namur standards how to write safe and securely back to the control system by applying, let's say, verification of request methods. That means proper authentication authorization at the edge level, and then at the control system level there is a proper set of rules validations happening for that set point before it goes to the OT systems to really do something on the field. So, I mean, edge I still see is the place where we kind of ensure the safety and security of the control system. But of course, we can't guarantee everything. But 62443 is another thing which we apply as a standard for security there.
So I think, because thank you for pitching in. So the question is, the edge management itself need to be upgraded by itself, right? How do you ensure it's cyber securely? Because within the process plan, the controls engineers may not let your gateway to be set up there. How do you manage the edge management?
Edge is deployed at level 3 roughly, so which is
Yeah.
kind of the middle layer of OT and IT. And we still kind of have today, even for our control system, applying the cybersecurity patches, which is happening from more or less level 3 and above to the level of level 2. So we have all cybersecurity practices established from there. And at the edge management itself, we also expect that either we can manage it from that zone, or if customers are willing to kind of provide internet connection to ABB cloud from where we can deploy, update the software containers on the fly, we can actually do it. I mean, their concerns are mostly around the data privacy, so they don't want the process data going out, but I would not see that they are not willing to kind of give us a possibility to manage and update the software without going to the site.
Thank you.
Kiran, can we take some questions from the audience?
Sure. Any questions on the current topic, what you're discussing, or the previous one also?
Doesn't look like. Why don't you move on and
Yeah.
you move the slide to the next one? Yeah.
Okay. Very specific to the digital transformation. So Sanjay, primarily when it comes to the digital twins, so what from the manufacturing side of the main production and as well as the maintenance operations, how do you see the digital twins are enabling the transformation of the operations?
First thing is, you can simulate or emulate, right? If you have put your foundations in place, right? We are doing for some of the customers, whether it is ABB, whether it is Siemens or anybody's, right? If you are looking for control and systems, many legacy upgrades you are having, right? So if you put in a right digital twin, not only simulation, you can actually put the physical PLC programmers or DCS programming onto that model, right? Optimize for the operations, for the incidences, right? And you know, just like a line on a bottling line, what point of time or how much time you have if this portion of the line fails. Is it 15 minutes? Do you have 5 minutes? Do you have 1 hour time? You can predict that, right? And directly you can offload the revised program into the line, right? So that's the extent we are seeing people are using this, right? Second thing is the preventive and predictive. Now I was talking about Gen AI, right? Once you have all this AI rule based, right? AI people have been doing for last 5-10 years in silos, lot of at least lines level, asset level, process level. We don't see much. Still, people are trying, but at least asset level and line level, not at a plant level, but there are successes. If you have put and go to the next level, the Gen AI is coming, right? Gen AI means, as I was talking about, large language models are possible where you have not, it's a not rule based that you will tell if this happens, do this. Gen AI models typically will enable you for the publicly available information or the large language model base that you incorporate with what you have internally, your intelligence or AI intelligence you have been building now, incorporate. It's a magnitude of change and transformation you can achieve. So my view is that a lot more can be done if you really enable this to.
So the management of change and as well as the
Yes.
maintenance, so
Yes.
you definitely see the digital twins will
A lot
add.
of value.
Yeah.
And my advice is anybody who is doing, typically what we are seeing and we are recommending also sometimes, you need to keep, it's not a one time exercise. You put all this engineering data, IT data, you clean up, but there has to be somebody responsible to make sure, just like in engineering model, if you are doing a plant maintenance and your HVAC or control system gets upgraded, it's very difficult sometimes to create the change process the right away you will get the data. But somebody dedicated, even one person who is dedicated, or a partner, supplier, your internal team, to keep this data up to date. Because 6 months down the line, even one, just like 1, 2, 3, the user goes and he finds the information is not correct. Because of 1% of that data not being confident in that data, entire 99% gets invalidated. And 3 years down the line, we all the time, it's like 20 years back, everybody got SAP properly implemented after 3 implementations. You don't want that to happen for your control and automations. And if you do this, at least you will guarantee that this 3 years, 5 years down the line, you will not discard the whole thing and reinitiate the whole thing again and again. That will be my 2 cents.
The life cycle process.
Yes.
Yeah.
Make sure that you invest in that. Yeah. Go ahead. Maybe you will have some point on that.
Yeah. Thank you, Sanjay. So Dave, I think very specific to the digital twin. So digital twin underlying, if you do not have the analytics, they do not really give the insights on the prescriptives, right? So how do you see the integrated fusion ET, OT, and IT data is enabling you to develop the prescriptive models rather than very condition asset specific models? Now you're able to give prescriptives also. So is that a fair say?
Yeah, I think so. For us, getting to more predictive, potentially prescriptive, right, is really getting into a lot of the physics-based models that we have. We have a lot of analytical models out there that run that give us good insight, but they always lead you to other things that you may not know, right? So we're out there learning as we go. But as you look at, turbine efficiency, pump performance, heat exchanger efficiency, we can see that pretty clearly, and actually give really clear direction on what to go do about those. So as we apply some of the functions and logics of digital twin, where we get the data in from the right sensors, from the right systems, that prescription becomes a lot easier in certain scenarios where we have those performance physics-based models. So that's helped us out quite a bit in capturing value, and at least helping the operations team stay running through that concept.
Okay, thank you, Dave. So while we are talking about data being available, but the reality is it's not actually having a single source of truth. What is the promise a unified namespace as an architecture is providing to the digital twin enablement, Vikas? If you can talk about unified namespace or a common integrated database where you can have a real-time streaming.
I mean, that's what, from our point of view, of course, very important to get the data into one common information model. It needs to be kind of understood by every application which is consuming the data without thinking, okay, this is a different source, that is another source, this is another source. What we do is try to get the edge, collecting the data from different sources, our own control system, maybe legacy devices using Modbus TCP, or OPC UA, as I said, is the kind of our main protocol to get the data. But we try to get this at the edge and contextualize them into one common information model, which is that applications can consume. And it's literally the key for us to succeed if we want to provide applications or data which they can actually use and deliver value for the customers into their digital transformation journey. So really, that's the kind of backbone at the edge where we have to ensure this is done correctly.
Okay, Thank
Kiran,
you.
we have about 5
Thank you,
minutes.
Vikas. So Larry, I think the question is now we are talking about AI models. We are talking about integrated data. What is the risk you see in terms of the cyber security for this?
I was hoping I'd get to talk about this point. Yeah. I think we're using AI without a lot of guardrails right now. Users have to look at this as a kind of three-dimensional problem, right? You have developers and you have people in your own internal organizations that are using AI tools that are openly available. Do you know how many of them are using them, or what they're using, or what kind of data they're feeding into those models? That could be sensitive corporate data, right? You need to have security around the use of those tools. You're also buying applications and products that have AI embedded in them from the suppliers, right? I don't care if it's a firewall with AI enabled configuration capabilities that make it easier for you to create your firewall rules or what have you, right? Just about every product now has some kind of an AI thing embedded in it. So that's something that you have to vet, and that's something that you have to incorporate into your supplier selection process. How are these suppliers using AI? Is this done in a secure manner? And then probably the biggest thing is a lot of these companies are developing their own large language models. Do you know if what you're developing is secure? I'll use the example, last year we had Georgia Pacific here, right? And they used this thing called Chat GP, you know? And what they've done is they've built this large language model where they fit in a lot of the knowledge of employees. Some of them are even employees that have been retired, for 10 years. And they take all the knowledge that these employees have and they built this model. So even a new worker can go in and ask this Chat GP, hey, what's the best procedure for cleaning this tank or what have you, right? So all that knowledge is kind of stored in there, but you also need to make sure that that's secure too, right? So I just encourage everybody, after you go home back to your organizations or whatever, think about that. Are you using guardrails? Do you actually know who's using what? Do you know that what you're developing is secure or not? So those to me are the risks. Yeah, we need guardrails and we need security with this too. So
Thank you.
Kiran, we need to wrap up. We run out of time.
Yep. I think we'll wrap up. I think on the GenAI promise, what we see, while GenAI, I think Larry talked about basically how the sensitive data has to be protected, secured. Across the industry, the process point manufacturing side, whatever agents and multi-agents you're trying to bring in, the RAG data, you're trying to make it secure and control on-prem, making sure you're not trying to take it outside the factory. But overall, I think from the managing the complexity of the process manufacturing data from an engineering to OT to IT. So the AI and GenAI are definitely a promise in terms of the transformation, acceleration, what you're able to bring in. At the same time, so whatever the solutions was taking more man hours, you're able to do it them faster. So AI is for sure, as I brought in an accelerated way of digitizing the data which was in legacy documents, legacy engineering artifacts. It is enabling to bring them. So ability to bring in more contextualized, prescriptive analytics is enabling the operations and maintenance to more incriminate these root causes and take prescriptive technical advisories at more reliable and robust manner. I think that's what I would say. And thank you in terms of talking about the various aspects from engineering to OT to how you consume your analytic models and how you make your AI and GenAI to your advantage. Thank you. Thank you.